Okay, so the problem in front of us reads, Patrick, Nora, and their friend Frank decided to build a triangular dance floor for their graduation party. They want to calculate the area of the floor plan in order to buy enough materials for construction. So there is a floor plan and it's triangular. I'm just going to illustrate the triangle over here so that I can talk to you about the next sentences. But we're not going to draw our accurate picture yet. I'm just trying to show you what the next sentences will mean. To figure out the dimensions, each one of the three people, stood at a vertex. So a vertex is right there, another vertex is right here, another vertex is right here. So those are vertices right there. Alright, let's try to draw based on the following sentences. Patrick standing at one vertex. So I'm going to make this smaller right there, and I'm going to illustrate Patrick by a point. And we're going to draw a small compass on top of that point so that it helps us with the bearings and directions they're giving us. So, Patrick standing at one vertex, spotting Frank east 30 degrees south. Okay, so it looks like we're going towards the south. East 30 degrees south means I'm starting from the east, going towards the south 30 degrees. Sorry for the horrible handwriting. Okay, I'm just going to say 30. So I'm going from the east towards the south. He's also spotting Nora, who's 20 meters away at a bearing of north 35 degrees east. North towards the east, and that's 35 degrees. So it's very important that we put our angles in the correct spot. From the north towards the east, because the north came first, so we start from the north towards the east. Similarly, previously on this angle right here, east 30 south, that means starts from the east. Alright, and Nora is 20 meters away, so that we gave the problem gave us this part right here, that this is 20 meters. Now, let's see. Here is Nora, and here somewhere is Frank. Alright, Nora is spotting Frank east 70 south. So from the east towards the south, 70 degrees. And I believe now that Frank is down here. That's why I didn't want to illustrate Frank by a point yet, because I wasn't sure if it's going to be, for example, between the west and the south, or east and the south. So we continue to read and we adjust our picture accordingly. So now we have all of the given in our picture, that Patrick is spotting Frank east 30 south, Nora, and he's also spotting Nora north 35 degrees east, and Nora is spotting Frank, so she's seeing Frank east 70 south, and now we need the area of this dance floor. So we're going to clean up our picture and see what we can do. Now, looking at our picture, we agreed that we're finding the area. That was the question. And to find the area, we agreed in class, or we proved in class, that we can use a formula that was pretty simple. I'll remind you of that formula. It says the area is half the base, and instead of the height, we proved that we can use another side and sine of the angle in between them. So instead of the height, since the height is equal to, or sine of an angle is equal to opposite over hypotenuse, we agreed that we can use this instead, and we proved that in class. Now we just have to remember that those two sides have this angle right here in between them, so they form side angle side. Well, we know it was given in the problem, put it right here so you would remember, that this side is 20 meters, I think. So therefore, we can figure out the area using our formula that we proved if we can find another side and an angle in between. So I can figure out this side and use this angle, or I can figure out this side and use this angle. It doesn't matter, I just need to find some angles here. So to find some angles, I need to know that this right here, this right angle is between the north and the east. This is a right angle, so I know that this is 55 because 55 plus 35 forms a 90-degree angle. So this angle in the triangle is 85 degrees total. Alright, so now I need to figure out some more angles to help me. I can do that by thinking of some alternate interior angles, and if you remember, alternate interior angles are between two parallel lines, and there is a transversal line in between. So if I follow my 35 angle right here, I can figure out that this angle is 35 as well. Well, my 5 is not that pretty, but you get the point. North and south lines over here, they're parallel, so if I follow my transversal, that line, I can figure out that this is 35. And we agreed it is very apparent, forms something like a letter Z. So letter Z. Also similarly, like we figured out that 55, this 70 degrees plus what would form a 90-degree angle? Because that's between the east and the south, and we know that this is a right angle. Yeah, plus 20. So that small angle right here is 20 degrees. Whoops, I didn't mean to write that. 20 degrees. Whoa. Alright. Well, 35 plus 20, that's 55. Agreed? So now, 55 plus 85 plus what would form 180 triangle? I can figure out that this one right here is 40. Because 85 plus 55 plus 40 would form 180, and there are 180 degrees in a triangle, so we're good. So we figured out this one as well. And we figured out that 35 based on alternate interior angles, and that's a 20 degree. I know it looks like 210, but it's 20 degrees. Let's see if I can fix it a little bit. Okay, so 20. Alright, so that's 20 degrees because 20 degrees plus 70 would form 90 degrees. It's a 90-degree angle. Okay, so now we have some angles and all of our angles and sides, and we can figure out sides by using the law of sines. I know that sine of an angle over the opposite side equals sine of the other angle over the opposite side, and it continues. So I can use that 20 because it's given to me. So I can say sine 40 over 20 because angle 40 is opposite to 20. That's 40 degrees, and that's 20 meters, and they're opposite to each other. And I can figure out another side. I can figure out x, this side right here, or y. Either way, I can say sine 85 over y or sine 55 over x. Either way is perfectly fine. You can do it both ways. There is no problem. No way is better than the other. I'll figure out x, just, it doesn't matter. It really doesn't. So you can do sine of 40 over 20 equals sine 85 over y equals sine 55 over x. And you can figure out x or y. Okay, let's see what we can do. By cross multiplication, we can figure this out. I have a small figure right here that's representing my drawing, so it's easier to follow. And we figured those angles from the previous slide. So by cross multiplication, we can figure out that 20 sine 55 equals to x sine 40. by dividing by sine 40 on both sides, because I want to isolate x, I can figure out that x is equal to 25.5 approximately meters. So now I can actually figure out the area, because the question will ask me about the area, so I'm definitely not done. So I can say that the area equals half of 20 times 25.5 sine, and I have to be very careful on which angle I use. I use this side and I use this side, so the angle in between them is 85. It's definitely the angle in between those two sides that I'm using. So sine 85 degrees. By plugging that in your calculator, make sure you're in degree mode. Of course, from the beginning we've been working with degrees, so make sure that your mode is in degrees. We can figure out that the area is 254 meters squared. And this is the solution to the problem. Hope that helps. Thanks.